Hello everyone, to the next session, the session about the Java Version Almanac. The Java Version Almanac is basically a collection of data about the history and the future of Java, currently mostly presented as a website. And during the presentation, I will have a look how I created this data collection, why I created it, and some things I learned during this little side project. First, some words about me. My name is Marc Hoffmann. Actually, I'm a Java hacker since the very early days, since the very early public, the first public release, which was Java 1.0.2. Java at the time looked like this. This was Javadoc at the time. There was no Javadoc actually. This is basically web rendering of some documentation which was done with some word processing, and in total we had just 8 Java packages. This was the whole JDK. So for example, if you look at the util package at the time, this was the whole util package. There was no data containers like map or list or set. There were only 2 implementations like vector and hash table. And if you look into that, this is how it rendered at the time, and this is how the web looked in the 90s. It was fancy to have like images for headlines like the constructors or methods headlines here. Really nice. Also, the beginning actually of Java was, as we know, on the client side, and the entry point was the Java Applet. And actually, my first commercial application I worked on was started with a Java Applet, so embedded in the browser. And from the applet you could start frames and open separate windows, but the runtime environment at the time was the JVM embedded in the browser. This is how everything started. Over the years I became involved in open source development. Probably one of my best known projects is the Java Code Coverage Library, Jacoco, and its integration into Eclipse called Eclemma. And out of that work, mostly in the area of quality assurance and testing, I started to contribute to OpenJDK, and over the years I also visited many conferences and had opportunities to speak at conferences, and finally became an organizer of unconference, or helped to unorganize the unconference in the J-Crete on the wonderful island of Crete, together with Heinz Karbutz and others. And a couple of years ago I was also nominated as a Java champion. Let's have a look back how the early days of Java looked like and how Java was released. So after 1996, when Java 1 was released, we've got Java releases like every 2 years, 2 or 3 years. And these Java releases, they were released at one point in time, and we could use them for many years in projects for production. And there have been updates, and it took a couple of years until there was the last public update of the JDK. So over the years the API evolved, we got new language features, and the tooling, the compiler, everything improved over the time. But what we can see here is things involved more or less slow. So for example, between Java 6 and Java 8, there was 8 years between those releases. So at the time, as a Java developer, it wasn't very stressful. So you could learn a version, JDK version, the new APIs, and could work for that for years. And this also was criticized of Java. And I want to show you a tweet which summarized this nicely. Like in 2016, people were complaining, Java is doomed. it evolves so slowly. Every good idea takes ages to be available. And just 2 years later, the perception was very different. Like, Java's doomed. It evolves so quickly. Nobody will be able to keep pace. Daniel Fernandez tweeted that. I really like that. And if we look at the timeline after 2016, we will see maybe the reason why this is. Since Java 9, we get new Java releases, major releases, every 6 months. So 2 releases a year. And every release contains new features, new APIs. So Java now evolves really quickly. But if you have a closer look, it's like only every 3 years there's a long-term support release. So as you can see on this diagram, the feature releases between the long-term support releases are end of life immediately when the next release is done. So you probably will not use that for production because it's only maintained for 6 months, and there's maybe 1 or 2 updates at most for these feature releases. So now every 6 months you see new features, and if you really want to keep pace and really want to attract the new features, you really have to follow the OpenJDK project and see what's going on there. I told you before that I'm also working on this bytecode library, the Jacoco code coverage library, which is based on bytecode. And with all these releases, we get new language features, maybe new JVM runtime options for the bytecode processing. And this also leads me to the point that I really need to understand what are the new features of the virtual machines to make Jacoco available even for the latest Java versions. And you need to test that. We will see that later. So my motivation to start the Java Almanac was basically we have a high frequency of releases, and I was curious what are the new language features for each release, what are the new APIs and the new bytecode options which are there. And this is, for example, the test matrix for the Jacoco project. Currently we test on 13 JDK versions from 5 to 17 and make sure the tool runs smoothly on all of these runtimes. So how did it all begin with the Java Version Almanac? So I did a lot of notes from presentation I attended or for presentation I gave myself, and over the years I got quite a collection of information about Java. And at one day I started collecting and writing down this information in a public GitHub repo. This looks like this at the time. This was basically just Markdown files, and you could browse them here on the GitHub interface. And I wrote down information about each release and what are the Java enhancement proposals for the JVM, for the language, or even in the library and the APIs, what happened here. Why Markdown? I mean, Markdown is a text format and it can be put under version control, so that's a natural way to work with. I also started using Markdown, for example, for presentations. So the presentation you're currently looking at is completely written in Markdown. There's a small framework called Remark.js, which renders the Markdown nicely as slides. And some people even write entire books in Markdown. For example, the one by Remy, it's called The Guide to Modern Java. I think it's work in progress, but it has some really interesting chapters, and everything is written in Markdown with lots of examples embedded here. You might have a look. And finally, I decided to convert that in a website to make it more accessible than the GitHub user interface. And this was actually when the Java Almanac.io website started. In case you haven't seen it before, the idea here is to have mostly reference information immediately accessible. For example, this version matrix provides direct links to the API, to the language specification, to the release notes, and there's also comparison between the APIs. So for example, we see what are the new APIs in Java 17 in comparison to Java 6. I will show you later how this is done, how this is created. So I wanted to have like a one-click reference because I basically created the project for myself, for my daily work. I wanted to see what are the new APIs and want to keep an eye on API changes. Also when learning new features, especially language features, for me it helps a lot to actually write about it and to write down how things work. This helps me in learning new things. So I wrote a couple of articles about new language features, and I call it in-depth content. We will have a look at that later. There's many distributions of OpenJDK nowadays, and the site should be vendor neutral. So also I included commercial distribution, commercial products on the site for reference, because if you live on Java and Java coding, you might end up actually using commercially supported products. And as this is a lot of content and this is all spare time work, for me it is important to automate as much as possible. So especially the data collection and the update of the data and the publishing should be automated where possible. I show you how this is done. This is a quick architecture view of the backend of the site. It basically uses GitHub infrastructure and a little bit of AWS components. For the GitHub, there's basically the repository where all the content of the site is stored and maintained. And the content consists of text files, again Markdown. And wherever possible, I try to convert the text files into structured data, JSON data, to make it accessible also by other use cases or for other use cases. This data and the text is converted into a static website. And for the static website rendering, I picked the Hugo static website renderer. This is written in Go. It's very powerful, very fast, and I really liked this project, and it's actively maintained. You see a couple of releases every year. I really liked it. So in case you need to create a static website out of Markdown documents, really have a look at the Hugo project. The website is then stored on the created app website is then stored on AWS. It's 3 buckets, and along with static content, which is not created by Hugo, for example, like historic Java doc or historic documents, I make accessible on the site. And everything is then made accessible through the web and with public endpoint, also with SSL termination, HTTPS, and here AWS CloudFront is like a handy and cheap tool to have a front end for your web projects, and it's also the front end for sandboxes, Java sandboxes. We talk about that in a minute. This is another nice feature I added to play with new Java versions. So as I told you, I try to be data-driven, work to be data-driven where possible, and I show you some examples here. For example, the information about every release is a structure, is a JSON document where, for example, release dates and documentation links are included. And with the Hugo rendering process, this finally then converts in nice HTML website with all the information included here. The same is for the API divs. The API divs are created by some process. We have a look soon about on this process. And JSON files are created from the div. Here, for example, is a difference between Java 9 and Java 8. And here we see, not very human readable, we see a structure of all the changes in this between two versions. And in the HTML, it renders like this. Now it's really accessible. And this is the new and deprecated or changed APIs in Java 9. And here's something sad. In Java 9, actually, the Java applet became deprecated. So how everything started now, applet is not the typical framework we use for application development nowadays. Nowadays, Java is, at least in my context, mostly used on the back end. And the applet that started everything in 1996 became deprecated with Java 9. Or you can also see all the other changes between Java versions, and it's basically a matrix. The site allows you to compare any Java releases, the API between any Java releases. Also, there's quite a few options nowadays to actually use OpenJDK. There's many vendors, and they provide different packagings for different platforms. And I wanted to have an overview of all the possible options to install Java for a specific platform, if you want to have a specific Java version. And I also collected that data in structured documents, and for example the adopt OpenJDK. Here you see what platforms are supported for example the version 8, and these are all the platforms. For example, if you want to run Java on your Raspberry Pi, you will find there's the corresponding package at OpenJDK, and this then also renders on the site. And for each Java version, down here, there's a table with all the different vendors. You see it's quite a few vendors nowadays that produce OpenJDK builds, and there's also quite a few platforms you can use OpenJDK for. And finally, because at least I do some work with Java bytecode, I added a little reference with Java bytecode. For Java bytecode, there's different sortings. You can see all the opcodes, and most important for me is I can directly jump to the specification and see the definition of these bytecodes and how they work exactly. So the hard part actually is collecting the data and keeping the data up to date. And as I told you, I tried to do as many things automated, but there's lots of manual collections and manual updates still. For the API divs, these are actually generated. So there's a process in place that compares two APIs and creates these JSON files with describing the difference. And here what is really helpful is actually Dockerized JDKs. So for all the JDK versions, or for the most JDK versions, you will find Docker images, for example for adopt OpenJDK, and also for the OpenJDK project itself, where we see early access releases like Java 17. I mean, Java 17 is not yet released. You will find very current and up-to-date early access releases, and this is really nice to test new JDK features. So if you want to follow the latest Java releases and the current development, I really recommend having a look at the early access builds, and if you don't want to install them locally, just use the Docker images. So there's quite a few JDK versions we keep track, and where we compare the APIs, and for this it turned out to be very useful to use matrix builds. This is a feature also for the GitHub Actions, and what you here basically do, you run the same build in with many different parameters. In this particular case, we run the build to extract the API with different Docker images. This is the Docker image name we use, or the base image, and this is then the JDK where we analyze the API and find the differences on bytecode again. So go through the Java library and process it with ASM library and extract information about the signatures of the class files. For the vendors, the list of vendors, you can study the websites, their websites, and some of them provide REST APIs where you can get information about their download artifacts, and instead of manually reading the websites, if there's no REST API, you can do some HTML scraping. Just if there's tables of information, just try to get the information out there. And here's something I want to share with you, because when I did the try to implement some HTML scraping, I came across a little library called JSoup, and in case you need to collect information systematically from the web, I really recommend having a look at that library. It's really great. So in this case, if I want, as an example, I want to grab some information from the Java Almanac IO page itself. Let's see, here's a table, and the table has here links to the Java doc. They are called API, the text of that links, and now the challenge is to retrieve all these links here, and that's actually pretty simple with that with the JSoup library. So you connect through the endpoint, for example, for get call. You can also do like post if you need to provide parameters, and then the nice thing here is that you select elements, HTML elements, with a CSS selector. So you don't have to write code that iterates through the document or searches some string tokens. For example, this case, I want to see the element which is in the table, in the row, and then in the cell. And we have the link which contains the text API, and this is the element we get, and we print out the URL this link points to. So that's a really nice and powerful tool to collect data from the web. The Sandbox. For every Java release, the site contains a sandbox with the latest version of that release, for example, the latest early access version. And this allows me to test and try new features without local installation. I can just go on the website, and for example, with Java 17, we have a new API to format binary data as hex strings. You might have done this before in your career as a Java developer, converting text representation of binary data in both directions. Probably every one of us did this before, and now finally we have a nice and handy API in the util package which allows doing that for us, and we can directly run that in the sandbox here, and the code is now compiled and executed on some backend service, like little Docker containers that execute this text. So how this is done? On the front end, the snippets are directly embedded in the Markdown files. This is a nice feature of the Hugo renderer. You can have like little macros here, and this allows me to embed like source code directly into the website, and then wrap up with the sandbox and make it executable. For the editor, here you see like a nice editor. I figured out that the ACE editor JavaScript editor is like a really nice and embeddable library where you have syntax highlighting and the typical features you expect from a programming editor. And for the interaction and the control, I decided to use the Vue framework, basically because I'm not a web developer and I didn't want to set up Node and everything. And the Vue framework you can just embed and just use as a library without complex build setup for that. The backend, the Java code is actually not executed in the browser. There's some service in the backend that compiles and executes your snippets. This runs in Docker images and it uses the compiler API of the JDK. So the JDK has some tooling APIs where you can basically use most of the JDK tools also via API, and this also holds true for the compiler. Here's an example. You can get this Java compiler interface and then directly feed in source files and compile them. And for example, in this case, we do it in memory. So source files are compiled, are not written to disk at all. Everything is done in memory, and this is possible with the tool API of the JDK compiler. And again, we want to have sandboxes for all the Java versions. So matrix build is our friend again. We've seen that before. We provide in some data to the build definition and have separate or different parameters of the build for all the Java versions up to Java 17. And for the Docker files we use, there's also a nice feature. We don't have to duplicate it and have to write a new separate Docker file for every Java version. Docker files can have arguments, and for example, we can put the define the. I need to scroll up a bit so you can see that. The base image can be an argument, and so you can reuse the same Docker file for all the different Java versions. This is really nice. And of course, we try to update this regularly, like every night. A GitHub action runs. Another nice thing about GitHub actions is also that you can schedule them periodically, and then the JDK or the sandboxes are updated. So in this case, for example, the Java 17 sandbox here at this point in time is the early access version build number 5. As I told you before, the site also has some articles about JDK features, for example, all aspects of method references. And here the sandbox is also very useful because example snippets can be directly embedded on the website and also executed on the website, and readers can try and fiddle around with the syntax and see how things work, and especially on the new Java versions without having to install the corresponding JDKs. And most of the articles in the meantime are provided by Kai Hoffmann. This is a nice collaboration. Kai is a creator of great Java content and Java books, so you might check out his website, hoffmann.com. You will find lots of nice articles about Java and also references to his books, so maybe you have a look at that. Because I'm a big fan to share knowledge and to learn together, of course everything is open source. I decided to use the Creative Commons license. So you are basically free to share and adapt the data and do whatever you want with that, as long as you stick with as long as you share it again. And all content is in the public Git repository. So there's no secret content. Whatever you've seen here, all the data behind that is publicly available in the Git repository, which is also linked on the site. Due to the fact that everything is open source and public, we have a nice cooperation also with Foojay. You've seen the previous session, and data, for example, about the Java versions is also rendered on the Foojay.io page, and they basically take the structured data, the JSON files, and render this in their context. We also share data about the OpenJDK vendors and product, and in the next session you will learn about how this is done at Foojay.io. Gerrit Grunwald will show you how they provide an API for the vendors and the OpenJDK products. So some outlook. So what are my plans and what I want to achieve in the future? First of all, there's for the API diffs, currently there's only technical API diffs, really the method signature, but it's not about semantic or documentation. And the OpenJDK project provides some diffs where not only the API but the Java doc is actually compared. And you can see diffs here, what changed actually in the Java doc. This might also be an interesting piece of information, and it would be nice to have diffs on the Java doc also. I would like to embed also examples for the APIs. So if you see new APIs, it would be nice to have a collection of examples how to use these APIs and the idioms, how the new APIs are supposed to be used. The JSON data you've seen before currently just sits in the Git repository, and it would be nice to also have them available through an API, like a REST API. That is also in discussion with the Foojay.io project, and currently looking for a technical solution how to make this data available. I'm thinking of like a static REST endpoint generator or something like that. And finally, in my wildest dreams, I would like to create a sandbox for Oak. So Oak was the predecessor of Java, like internal project at Sun at the time, and this is how everything started. And I think it would be really, really cool to have a sandbox with the original Oak runtime, but I have no contacts and I don't know whether the source code actually exists or binaries still exist of the Oak runtime and the Oak compiler, but it would be really nice to maybe find some resources about this and actually create an Oak sandbox where you can study and see how everything started 25 years ago. So thanks a lot for attending this little presentation. If you have any questions, I'm around for the next minutes here, and I'm happy to answer your questions. Thank you.